Today we will be learning about the Iupac system of naming. This system is designed by a whole group of people called the International Union of Pure and Applied Chemists, and they've designed a system of naming that everybody in the world uses. It is a very systematic pattern of naming that we will start with the hydrocarbons first, then we will extend it into the functionalized groups. In the Iupac naming system, there are 4 parts to every name. The first part is actually at the end, and it is a description of the class of compound, like you might describe your home as a condo, a house, or an apartment. In front of that, we'll be putting in the next part of the name, and that will be the size of it. This is a 1-story condo, a 2-story condo, a 3-story condo. Whatever it is, you'll put the size in at that point. In front of that, we'll put in some details. It has a door, it has 2 windows, it has a balcony, wherever they are. And finally, you need to tell the locations. The locations tell us where the detailed parts are and sometimes where the class of compound is identified. So the location is very important to identify where all of the details and the class of compound might be found. As I teach you this naming system, I will often start at the very end, classification of the compounds. Then I'll ask you to find and identify the main chain, then identify anything that's attached to the main chain, and finally figure out the numbers. We always work backwards because we need to know what the basic structure is in order to say what's an attachment. For example, in this compound, we would see that it has all carbon-carbon single bonds and that there are no oxygens or nitrogens. So we would say that this is an alkane, giving us the suffix ane. Next, we would look for the longest connected carbon chain. In this case, we have 1, 2, 3, 4, 5 carbons, and that makes it pentane. So we get the main chain name as pent, and we add that onto the suffix ane. Next, you can notice that we have this Br attached to the main chain, and so we're going to put in the prefix bromo, and in front of that we're going to list where it is located, and that is on carbon number 2. So the whole name will become 2-bromopentane. In a moment, I'll tell you where we get all of those parts. We can also go the other direction. Here, I've given you a name, and you should be able to draw what the chemical looks like. Where we start with is also going backwards. We'll start with the ane at the end. That tells us that everything is going to be single bonded. Then we see the part that says hex, the main name, and that tells us that there are 6 carbons in the main chain. All of those should have single bonds between them. Next, we put on a fluorine. Where we put it is on carbon number 3. We attach the fluorine, and now what we're left with is a whole carbon chain. This is the carbon skeleton. After that, we're going to add in the hydrogens to make sure that we have 4 bonds on each carbon. And that is our compound 3-fluorohexane. The first thing we need to do is to learn how to count in organic chemistry. So we're going to look at these words, and you'll notice that they are in 2 parts. For the first one, we see meth and then ane. For now, we are only going to focus on the first part. Here we see meth, and that means that there is 1 carbon. Eth means 2, prop means 3 carbons, but means 4 carbons, pent means 5 carbons, hex means 6 carbons, hept means 7 carbons, oct means 8 carbons, non means 9 carbons, and dec means 10 carbons. The second part of the name, ane, is telling us that this is a alkane, which means it's all single bonds between the carbons. You will need to memorize this list in order to start doing organic naming. Without it, it will be very challenging. When we talk about organic compounds, we focus on the carbon chains. There are usually 2 different types. There's the main chain and a side chain. A main chain is the longest connected carbon chain where you can follow along without having to go back and forth. On the other hand, a side chain is a branch that sticks off of the main chain. Note that the main chain does not have to be a straight chain. They just need to be the longest connected carbon chain. Below you will see some carbon skeletons where you will be asked to identify the main chain. So let's start with compound A. Notice that there are 4 carbons in a straight line, and there's 1 coming off as a branch. So the main chain here has 4 carbons, with a 1-carbon branch. In this case, you could have picked either the left-hand carbon or the one that's pointing down to be part of the chain or part of the branch. Now let's look at compound B. How long is the longest connected carbon chain? When people first see this, they usually say 6 carbons. But you should see that this chain is actually 8 carbons long, starting from the bottom and going up, and then going up again to the end. In this case, I have 2 branches, one with 1 carbon and one with 2 carbons. Now let's look at compound C. What is the longest carbon chain? Did you pick 6, 8, 11, maybe even 14? Well, the answer is 11. So if we follow this from the upper right-hand corner and count backwards, we get to that point where there's a branch with 3 carbons coming off of it. Go down, follow it around, and come back up on the other side, and you'll see that there are 11 connected carbons. There are also 3 branched carbons, 1 carbon each, for a total of 14 carbons. But again, the main chain is only 11 carbons long. Okay, last one. Letter D. How long is the longest connected carbon chain? Hopefully you got 8. And you can see that there are 3 side chains, each with 1 carbon long, total of 11 carbons, but 8 is our main chain. You now would be able to do a part of the naming for each of these. For all of them, they're going to end with -ane, because they're all alkanes. In front of that, you'll put in the number of carbons in the main chain. So for letter A, we have 4 carbons in the main chain. That will be butane. For letter B, we had 8 carbons in the main chain, and that will be octane. And letter C, you don't know this one, it's not in your list, but if you have 11 carbons, it's called undecane, like undies, Undecane. So undecane. And letter D, we're going to find that we had 8 carbons long, so this will be another form of octane. Now the fact that we have 2 different octanes, but they are attached in different ways, these 2 are going to be called isomers. We'll discuss that much later. Now we're going to focus on those side chains, also known as substituents. The first type of substituent we can look at are the alkyl side groups. Here the alk means hydrocarbon chain and the YL means attached. So we're looking at carbon chains that are attached to the main chain. These are sometimes called R groups, just standing for alkyl chains. So let's look at the first one. First we have meth and then YL. So we break all of these words into 2 pieces, meth, YL, ethyl, propyl, isopropyl, and butyl. The meth means 1 carbon side chain. Eth means 2 carbon side chain. Prop means 3 carbon side chain. I'm going to skip the next one for a moment. And then we go down to but, and it means 4 carbon side chain. These are all attached to the main chain, with the YL telling us that it's an attachment. Now I did skip isopropyl, and I need to go back to that one. In this case, we have prop in the middle of its name. That means that there are 3 carbons. But the iso says that it is not attached at the end of the 3 carbons, but rather in the middle of those 3 carbons. It doesn't matter where it is on the chain, it only matters that it is attached to the middle of the 3 carbons in the propyl part of the chain. Another very common substituent are the halogens. In this case, it's very simple. If it's a fluorine, we're going to call it fluoro. If it's a chlorine, we'll call it chloro. If it's a bromine, we'll call it bromo. And if it's an iodine, we'll call it iodo. And again, these are attached to the main chain. In this case, the O is telling us that that halogen is attached.